Hello, mathematicians. Today we're going to look at limits analytically. First, let's look at this piecewise function. Given the piecewise function, f of x equals x plus 2 when x is greater than or equal to 0, and 3 minus x squared when x is less than 0, determine the limit as x approaches 0 of f of x. To do this, we first need to find the limit from the left, then the limit from the right, and see if they're the same. So first, when we're talking about the limit from the left, that means x is less than 0. So we're going to be using the second part, 3 minus x squared. So when we plug in 0, 3 minus 0 squared, get 3. And if we're going x approaching from the right, that would mean that x is greater than 0. So we're going to use the first one, x plus 2. And if we plug in 0 here, we get 0 plus 2, and that is 2. So if the limit from the left is 3 and the limit from the right is 2, what does that tell us about the limit as x approaches 0? Well, it doesn't exist because the two sides are not the same. Now, in some cases, you might have noticed that we get results of the form 0 over 0 or infinity over infinity. That is called indeterminate. If we have an indeterminate form, we have to do some algebraic manipulation to try and figure out what it will be. One method to try is factoring. So first, we always want to try and plug in our values. So if we do limit as x approaches -4 of x squared plus 6x plus 8 divided by x plus 4, first thing we want to try, plug in. So when we plug in -4 squared plus 6 times -4 plus 8 over -4 plus 4, we're going to get 0 over 0. This is one of our indeterminate forms. So let's try to factor. One hint with factoring is that usually your denominator is one of your factors. But as a reminder, let's go from the beginning. To factor, first we need to find what is our b. b is always the number with our x term. So that's 6. c is 8. So now we need to find what numbers can we multiply to 8 that add to 6. Well, 2 times 4 is 8, and 2 plus 4 is 6. So when we factor here, this will be limit as x approaches -4 of x plus 2 times x plus 4 divided by x plus 4. Do you notice anything we can do now? We can cancel. The x plus 4's cancel. So we get limit as x approaches -4 of x plus 2. Now, if we plug in -4, we get -4 plus 2 is -2. We've gotten rid of our problem. When we can get rid of our problem, that tells us that we have a removable discontinuity. So most of the time, this graph looks like x plus 2, but it has a hole at x equals -4. So this tells us we have a hole at x equals -4. We can remove this continuity. Okay, let's try another case. Again, always want to first try to plug in. Okay, when we plug in here, we're going to try and plug in 0. So we're going to get 0 plus 4 square rooted minus 2 over 0. Well, this 0 plus 4 is 4. Square root of that is 2. 2 minus 2 is 0. We have 0 over 0, so let's try another method. When we have square roots, we want to use the conjugate. The conjugate is you take whatever not in the square root but that separates them, the sign that separates it, and you change that sign. So the conjugate, let's say, of 3 plus square root of 2 would be 3 minus square root of 2. The conjugate of 3 square root of 2 minus 10 would be 3 square root of 2 plus 10. What is this conjugate that we're going to use with our numerator? Well, it will be square root of x plus 4. That's in our square root. Then we change that middle sign, plus 2. And now we can't just multiply by something. We have to keep it equal. So we'll multiply by the same thing on the top and the bottom. When we do that, this is like FOILing. We'll do the first times the last, and then the second one. And always what will happen, because we have the different signs, is that we will get x plus 4, square root of x plus 4 squared, and then negative 2 plus times positive 2 will be negative 4. The middle terms will cancel out because one will be positive and one will be negative. In the denominator, leave it as it is. X times square root of x plus 4 plus 2. And we're taking the limit as x approaches 0 still. Now, if we square a square root, they're going to just cancel. So we will have x plus 4 minus 4 over x times x plus 4 plus 2. Now the plus 4 minus 4 cancel, so we'll just have, oops, I need to put my limit there. They'll take off points on the AP if we miss that. Limit as x approaches 0 of x over x times square root of x plus 4 plus 2. Now do you see anything that can cancel? Yeah, these x's. So we'll get limit as x approaches 0 of 1. Remember, when you cancel out and there's nothing left, you're going to put a 1. Square root of x plus 4 plus 2. Now we've removed our problem. So as x approaches 0, when we plug in, we get square root of 0 plus 4 plus 2. Square root of 4 is 2 plus 2 is 4. 1 over 4. Note, you only stop writing the limit when you plug in. When you plug in, you can stop writing the limit. Otherwise, you need to write the limit over and over again. Okay, the last way that we're going to learn is with a common denominator. This is used when you have ugly fractions within fractions. So to get rid of them, you're going to multiply by the common denominator. The common denominator, well, first actually plug in. So we get 1 over 0 plus 5 minus 1 over 5 over 0. Well, that will be 1 over 5 minus 1 over 5 is 0 over 0. Okay, so now let's try using our common denominator. So the denominators of our fractions here are x plus 5 and 5. So our common denominator is 5 times x plus 5. Multiply the same thing on the top and the bottom. So we get limit as x approaches 0. Now when we distribute to this one, the x plus 5s will cancel out. But I'm going to write it all out so you can see. 5x plus 5 over x plus 5 minus 5 times x plus 5 over 5 all over x 5 times x plus 5. So let's do some canceling out here. These will cancel, these will cancel. So we're left with limit as x approaches 0 of 5 minus x plus 5 divided by 5x x plus 5. So now we have, when we distribute this, we'll have 5 minus x minus 5. So the 5's will cancel out. So we will have limit as x approaches 0 of negative x over 5x times x plus 5. Can we cancel anything? Yes, these x's. So we get negative 1, remember we have that negative here, divide by 5 times x plus 5. Oh, I did it again. Limit as x approaches 0. Now, let's try plugging in 0. We get negative 1 over 5 times 0 plus 5, negative 1 over 25. So in all three cases, when we got 0 over 0, we were able to manipulate it using these different methods to get an actual number. So remember, if you have a fraction, use the common denominator. If you have a square root, use the conjugate. If you have polynomials, try and factor. But number one, plug in.